Section 9.4, Special Right Triangles. By the end of this lesson, you should understand how to find the side lengths of special right triangles. Special right triangles are triangles with the measures of 30 degrees, 60 degrees, and 90 degrees, or 45 degrees, 45 degrees, and 90 degrees. And the reason why these triangles are called special right triangles is because there's a special relationship between the lengths of their sides. In 45, 45, 90 degree triangles, the hypotenuse is root 2 times as long as each of the legs. So for example, if we know that one of the legs is 5, then that means that the hypotenuse is going to be 5 radical 2. When we're solving these types of problems, it's sometimes helpful to have a diagram or a chart to help us organize our information. The first row in this chart is the angle measure for the triangle. The second row in the chart is the relationship between the side lengths for this angle measure. And then the last row in here is where we're going to actually put the side lengths that are given to us from this triangle. So for this one, we see that we have across from one of the 45 degree angles is the measure of 7. So that's one of the lengths of our legs. Across from the other 45 degree angle, we have y. So that's one of the variables we'll need to find. And across from our right angle is our hypotenuse, and that is x, our other variable that we'll need to find. Now once you have this information in your chart, you can take a look and see which one you had the length of the side length given to you. So for us, we're given that a is equal to 7. You can rewrite this and use it to help you solve for the other side lengths. So since a is equal to 7, then that means anywhere in our chart that we see a, we can go ahead and substitute 7 in place of it. So that means that this is 7, and for this column we have 7 radical 2. We can then simplify this and we know what each of our variables is going to be equal to. So we know that y will be equal to 7, and we know that x will be equal to 7 radical 2. Now this is one of the basic problems for 45, 45, 90 degree triangles, and you may have been able to figure out the side lengths without having to use this chart, but this chart is helpful for when we get to side lengths that have radicals or maybe in a form that you're not used to. For 30, 60, 90 degree triangles, the hypotenuse is twice as long as the short leg, and the long leg is going to be root 3 times as long as the short leg. We know that it's the short leg if it is opposite of our 30 degree angle, and the long leg is going to be opposite of our 60 degree angle. The hypotenuse will always be opposite of the right angle. So here we need to find the value of the variables again. I know that it's a 30, 60, 90 degree triangle because of the angle measures that are given to us. So we can go ahead and use our chart once again. Just like the chart for the 45, 45, 90 degree triangle, we'll have the angle measures listed in the first row. I have the relationship between the side lengths in the second row, and I'll go ahead and record the side lengths that were given in the bottom row. Across from the 30 degree angle, we have the measure 15. So I'll go ahead and put that in the 30 degree column. Across from the 60 degree angle, we have the variable x. So we'll put that in the 60 degree column. And across from the 90 degree angle, or our hypotenuse, is y. The next step in this is we're going to take a look and see what the relationship is for the side length that was given to us. And we can set this equal to it. So I know that a will be equal to 15. Because a is equal to 15, that means anywhere else that I see a, I can substitute in the value 15. So we'll have 15 radical 3 for x, and we will have 2 times 15 for y. When we simplify, we'll be able to say that x is equal to 15 radical 3, and we'll also be able to say that y is equal to 30, because 2 times 15 will give us 30. And that's really all that we're going to be doing for 45, 45, 90, and 30, 60, 90 triangles. We're going to practice this much more in class, and make sure that you have these notes handy for when we do practice them. So here's our joke. What lies at the bottom of an ocean and twitches? A nervous wreck does.